Hello everybody, in this video I will teach you how to solve exponential equations and I will discuss the examples you see on the screen. Solve for x. So now you will see that your variable is the exponent. This is why this is called exponential equations. Now what you do is on the right hand side you find the number 125 and you are going to prime factorize 125 and that is 5 to the power of 3. And then there's a law, an exponential law that says when your bases are the same you can equate exponents. Therefore x is equal to 3. The second example, solve for a. Now your problem here is your bases are not prime numbers. So 8 you can prime factorize and it becomes 2 to the 3 raised to the power a plus 5, and 16 prime factorized is 2 to the 4 raised to the power 2a plus 3. Then the law, your bases are the same, therefore you can equate exponents and it becomes 3 bracket a plus 5 is equal to 4 bracket 2a plus 3. Now to get rid of the brackets you will multiply in the 3 and it becomes 3a plus 15, and you can multiply in the 4 and it becomes 4 times 2a is 8a and 4 times 3 is 12. Now let's get all the variables on one side and all the numbers on the other side. So I'm going to let the 3a walk across to the right hand side and the 12 across to the left hand side. So it becomes 15 minus 12 is equal to 8a minus 3. And then 15 minus 12 is 3, and 8a minus 3a, when you add like terms, is 5a. And then to solve a, divide by 5, divide by 5. Therefore, a's value is 3 over 5. Solve for a. And then I give you 2 to the 3a is equal to a quarter, this fraction. But don't be scared, because the rules of exponents says that you can write a quarter as 4 to the power of negative 1. And then when you prime factorize 4, it becomes 2 to the power negative 2. So a quarter is 2 to the power of negative 2. And then you can say your bases are the same, therefore you can equate exponents and it becomes 3a is equal to negative 2. And then to solve a, divide by 3, divide by 3. A is negative 2 over 3. The next example, solve for b. And now I give you 9 times 27b to the power of b is equal to 81. So what you're going to do here is you are going to divide away the 9. And then it becomes 27 to the power of b is equal to, on the right hand side, 81 divided by 9. And then 81 divided by 9 is 9. So on the left hand side you find a 27. So you're going to prime factorize both sides. And 27 is 3 to the 3b equals, and 9 prime factorized is 3 squared. And now you can say bases are the same, therefore we can equate exponents and it becomes 3b is equal to 2, and to solve b, divide by 3, divide by 3, and b is 2 over 3. Solve for x. And then I give you 7 to the power x minus 5 is equal to 1. Now, the laws of exponents tells you that there's a law that says anything to the 0 is equal to 1. So now, in this case, the other base is a 7. So we can write 1 as 7 to the power of 0. So that you're back with bases are the same, therefore we can equate exponents and it becomes x minus 5 is equal to 0, and solve x, let the 5 walk across. So x is equal to 5. On the right hand side, I give you solve for x, and then I give you that. And it looks very intimidating, but don't be scared. It's the 1 that's the problem here. Remember, the law says anything to the power of 0 is 1. So in this case, the other base is a 5. So in the place of 1, you can write 5 to the power of 0. And now this is the base 5 on the left and base 5 on the right. Therefore, bases are the same. We can equate the exponents. Now this one is a quadratic equation that you can solve, because that was what was discussed in the previous lessons. But here is a problem. Your quadratic equation is not in a proper standard form. That means you have to rearrange your terms, and you get it into standard form by writing x squared x number. Your numbers and variables have to be in a proper descending order. Now it is in standard form, equal to 0, of course. And now we're going to factorize. So we say the factors of 5 are 5 and 1. The factors of 3 are 3 and 1. I want the middle term to be 8. 5 times 1 is 5. 3 times 1 is 3. Can 3 and 5 give you 8? Yes, indeed. So then your brackets, your factors will be bracket 5x minus 3 and bracket x minus 1 equal to 0. And then you say 5x minus 3 is equal to 0, or x minus 1 is equal to 0. Let's solve x. 5x is equal to 3, so the negative 3 will walk across and it becomes positive 3. Divide by 5, divide by 5. X is equal to 3 over 5. And then the other one, where there's x minus 1, let the negative 1 walk across and it becomes x is equal to 1. Solve for b. And then in this equation, now there's this decimal 0,125. But 0,125 is exactly the same as an eighth. And then an eighth, you can write it as 2 to the power of negative 3 is equal to 2 to the power b squared minus 4x. And then you find there's a base 2 on the one side and there's a base 2 on the other side. Therefore, bases are the same. We can equate exponents. Minus 3 is equal to b squared minus 4x. And then let's turn this one into a proper quadratic equation. It is in standard form. 0 is equal to b squared minus 4x plus 3. And then I can factorize. The factors of 3 are 3 and 1. I want the middle term to be negative 4. How can 3 and 1 give you negative 4? Negative 3, negative 1 is negative 4. Therefore, 0 is equal to bracket b minus 3, b minus 1. Let's solve b. b minus 3 is 0, or b minus 1 is 0. And then b is equal to 3, or b is equal to 1. In the next video, I will discuss literal equations. Click on the video in the left-hand corner to take you straight to the next video.